Global agriscience leader Bayer Crop Science drives OEE using Edge2Web and AWS. I'm Fred Holohan, co-founder and CEO of Edge2Web.
I'm Krishna Dodapaneni, worldwide tech lead for industry partners in IoT at AWS. What you've learned from our partners and customers in the industrial space is that they are looking for a standardized industrial data foundation that helps with building interoperable, secure, and cost-efficient solutions in the industrial space. They are looking to make sense of data that is historical and real-time, that is coming from equipments, sensors, SCADA historians, and enterprise data in order to build solutions, including making sense of that data using all this data that is generated on the site for security reasons as well as improving performance on their systems. This is where Sitewise plays a role. AWS IoT Sitewise is an industrial service that is built for industrial data foundation that helps you with bringing a single and organized view of your assets. It helps you build with simplified data ingestion and contextualization.
Edge2Web is a software provider that provides applications and tools that ride on top of AWS Sitewise to help industrial companies build applications that solve a wide range of use cases. In the context of this talk, where Bayer Crop Science has used our tools on Sitewise and other IoT infrastructures to build a very powerful global application, we'll be talking about how Edge2Web tools are used in a manufacturing context. This diagram shows the stack of Edge2Web products as they ride on top of AWS Sitewise. So at the bottom of the slide, we have Sitewise, and working our way up, we have Edge2Web Low-code Tools, which are used by application developers to build a wide range of industrial IoT applications. Moving up the stack are Edge2Web No-code Tools. They're used by non-programmers, control engineers, quality analysts within a plant to build applications that compute custom KPIs, display data in custom scorecards, dashboards, and so forth. And at the top of our stack, we have Factory Insights, a ready-made application that's targeted at discrete manufacturers, allows them to very quickly materialize their Sitewise data and use the generated KPIs to improve machine availability, product quality, and line performance. Let's now talk about how Bayer Crop Science is using these tools to field a global application that is intended and is now operating to improve their manufacturing operations. So Bayer Crop Science, which used to be known as Monsanto, is a company that is all about providing products to farmers to help them grow better crops more quickly with fewer resources. Bayer's product line is primarily comprised of 3 different types of products: seeds, amendments to those seeds, and pesticides and herbicides. In the application that Bayer's built using Edge2Web tools and AWS Sitewise and so forth, we're working primarily with the seed and the seed amendments parts of the Bayer organization. They produce seeds for corn, cotton, and soy, and again, their objectives are to provide farmers with better yields, higher quality, using fewer resources. 4 or 5 years ago, Bayer set out with a sort of a self-assessment program to identify places where they could improve the efficiency of their manufacturing operations. And so they came up with a target list of challenges that they wanted to overcome with an application they would build using our tools on a cloud IoT platform. So they wanted to reduce the amount of downtime, unplanned downtime in particular, of their assets. At the time, they understood that they had inconsistent ways of measuring their performance, and so they wanted to smooth that out. They found that it was difficult to compare performance across sites and across product lines. And like many manufacturing organizations, they conducted a lot of their business on paper and in spreadsheets and so forth, and they wanted to move away from that. So they created a group of goals for the application that they would build, and those goals ranged from creating a cloud data analytics platform that would allow them to compare, move data into the cloud, build analytics on top of it, and then compare the performance of their sites and their lines within those sites, something they couldn't do when the data was locked into their factory silos. They set out a number of other goals, but primarily were oriented toward improving machine availability, improving product quality, and improving the throughput of their manufacturing lines. They also wanted, obviously, since they were doing so much on paper, to digitize those paper processes so they could make them more consistent and take advantage of the domain expertise that existed within their factories. And importantly, when this application that they were contemplating was ready to roll, they wanted to be able to roll it out to 50+ manufacturing sites across 3 continents on the globe with minimal disruption. And that last point is really important because it means that the application itself had to understand the terminology that the shop floor workers were using in those plants, the processing conventions, the machine groupings that needed to be evaluated and so forth. So the application itself had to not only compute metrics, but it had to deliver the information in a way that would be readily understandable to the target audience so that they could deploy the application, roll it out very quickly. So those were the goals, and this is the roadmap. It actually began a little bit before 2021, but essentially it tracks to a lot of large-scale application projects. So the initial stages were product scoping, doing a POC, selecting vendors, including us, and then working on how they would move plant data from the factory silo into the cloud, and then develop the application, test it, and then in 2023, they began that rollout process. They had to, of course, continue to improve the application as they rolled it out, so there were challenges in doing that, which they were able to easily overcome. And 2024 is all about scale out of the application. So by the end of this year, they will have deployed this very large, powerful IoT application across more than 50 sites in 3 different geos. So we've heard a little bit about their goals, their challenges and goals, and their roadmap. What does the application look like? So this slide has a few different visualizations that are running now in the majority of the Bayer plants worldwide. And these visualizations, behind these visualizations, Edge2Web is accessing data from SiteWise and other IoT platforms, computing a variety of KPIs, and then visualizing those KPIs for their frontline workers, their line supervisors, and their plant managers using screenshots like we have here. Line performance, hourly OEE, downtime category analysis, availability Paretos. These are just a few of the many different visualizations and dashboards and scorecards that Bayer has created as a result of the goals they had set out for this application to begin with. If we look underneath those visualizations at their tech stack, we see that it's actually a hybrid infrastructure. They are using Sitewise. They're also using Siemens Insights Hub as their IoT bedrock in the cloud. And above that infrastructure, there are a variety of different Edge2Web products that combined create the solution they're now rolling out to their plants.
So we have machines, we have PLC systems, we have SCADA systems on the factory floor. In order to bring the data and metadata into the cloud, there are 300 odd protocols in the market today, and AWS supports some of them natively, and for the others, we depend on our partners. We grew our partner ecosystem to support all the leading protocols in the market today from factory and oil and gas industries. In this case, we used a partner edge application that sits on top of our gateway and our runtime called Greengrass. As data is flowing into the edge, it lands in Sitewise in the cloud. Now, not just data, but also metadata and asset hierarchy of that factory is now available in Sitewise. Now, why do we need to send the data to Sitewise? There are a few reasons. One, you can visualize it natively with the help of Sitewise Monitor. You can push the data into a data lake, import it and export it into an S3 bucket easily. Then you could also connect to AWS managed machine learning services like Lookout for Equipment. And finally, with the help of TwinMaker, you can also create digital twins of your factory setting to understand how your machine performance on just sitting in your office.
And I would add to what Krish is saying, a huge benefit of moving the data from the factory silos into the cloud, into Sitewise, is that, number one, it serves as the data foundation for the initial application they've envisioned. But number two, it serves as a foundation to do all types of future analytics and machine learning and so forth. So really, by taking that first step and getting the data into the cloud, into Sitewise, Bayer is positioning themselves to become a truly data-driven organization going forward. And so what does the deployment footprint look like now? They're now rolling that application out to 3 regions. The application itself supports 7 different local languages: English, Spanish, French, German, and so forth. You can see that at the current time, they've rolled it out to more than 40 sites. So they've achieved their goal of minimizing the disruption of the rollout, which is often a problem when you're deploying an application of this magnitude. Lots of assets, and the number of assets being managed by this application are growing at a very good clip. And at the current time, more than 1,000 users, but that user population is growing very quickly as well. And if we look at who some of those users are, they are machine operators, they're process engineers, they're quality engineers, plant data analysts, line supervisors, and plant managers. Each of those different user personas has a different set of scorecards and dashboards and a different ability to look at the data and, in some cases, even change the data to improve the quality of the metrics that are produced by our KPI engine. So if we look at what Bayer set out for as goals and compare that to where they are today, they were determined to create a cloud infrastructure that would be the foundation of a data-driven analytics business going forward, and they've achieved that. They are now reducing the unplanned downtime of their equipment. They're improving their production line performance, and they've actually got some measurements associated with that. They are, importantly, allowing their machine operators and quality engineers to actually change the data once it's been ingested into SiteWise. And you might ask, why would they want to do that? Well, the answer is because as the data flows from the plant to the cloud, sometimes the precision of the information as it's captured off of the controller devices, PLCs, and so forth, is not significant enough or precise enough to allow KPI computation that really allows them to understand their business. So for example, a PLC might report 10 different state codes, states of the machine in operation. So, everything from the machine is on, the machine is off, the machine is paused, it's offline for some reason. That level of information, that level of data was not sufficient for Bayer to compute the types of KPIs, the accuracy of the KPIs that they wanted to deliver from this application. And so part of the requirement was for them to allow their machine operators and quality engineers to actually inspect the data as it had flowed into the cloud and change it. So for example, if the controller device is reporting that a machine is stopped, it's paused, that machine operator might know it's stopped because it's blocked, or it's stopped because it's starved, it's waiting for product. Or if the controller is reporting that the machine is offline, that operator might know that it's offline because of an unplanned electrical condition. Being able to amend the data with that type of on-the-floor frontline intelligence allows the data to be more precise in driving the KPIs that will change Bayer's business. And so that was a key objective, and it's one they've achieved, and is really benefiting them now. They're on the journey to digitize their paper processes and move out of spreadsheets and so forth. And as I've mentioned a couple of times, because the application was built with the idea of minimizing rollout disruption from the beginning, they are now accelerating their rollout plan. This is a quote from our key guy at Bayer Crop Science, Dave Kaltmeyer. And even though he's speaking to Edge2Web in this quote, I actually think that he's speaking to all of the stakeholders who are involved in this application. So he's making a comment about us, about AWS, about Siemens, about our systems integration partner, Engineering USA. There has been a great collaboration among the stakeholders in this application to deliver the goods for Bayer, and that performance is reflected in this type of comment. So if we tie a bow around this, the key takeaways for Bayer are the objective of getting their factory data out of those silos into the cloud, into an open, democratized IoT platform, gives them the ability to achieve their short-term objectives, but use that data in ways they can't even contemplate today. AWS IoT SiteWise has delivered the goods for them. So it is a wonderful platform for ingesting factory data, managing it, organizing it, storing it, and making it available to the Edge2Web tier, the application tier, so that we can do our job and compute those KPIs and visualize that data. And on our side of it, our solutions, both in terms of applications and tools, are giving Bayer the flexibility to accomplish their short-term goals, but also drive into the future based on that platform. So with that, I will invite any questions, if there are from the audience. All right, well, thank you very much for coming. I appreciate it.
Thank you very much.